So I stumbled upon some statistics, and I was just curious for the most part because I wanted to see if there was something off about where people were giving their attention, and I found a definite pattern. I have this paper here. It has some graphs on there. I'll link this to the bottom so you can see it. I know how some of these videos don't show up very clearly. Using basic Wikipedia page view statistics, it is apparent astronomers are trying to figure out where they went wrong. As well, it is apparent that in 2017, it was a year for maximum acceptance of the nebular hypothesis. It is now on a downward slide. This is due to it not being a useful hypothesis in explaining any current observation by Kepler, TESS, or any space or ground-based exoplanet evolving star hunter. The replacement theory, stellar metamorphosis, is used to explain to the astronomers why they have gone so wrong for so long. Very wrong for very long. That's the astronomers' MO. That's how they like to do things. The more wrong they are, the more money they get, I guess. That being said, the money is moving in other directions, so they can't be wrong about the nebula hypothesis anymore because the money is starting to flow in other ways. You got to follow the money, and I think that's the best option. Find out what gets the most money, and then you chase that. As an astronomer, that's the wisest choice. Following stuff that makes sense but is unprofitable, no, you don't want to do that because you can't put food on the table. You always have to make sure you get paid. That's number one. If it just so happens to be that the idea is accepted by a lot of people and it's correct at the same time, well then that's a plus. But being correct isn't necessary. All you need to do is make sure that you get the money flowing, and that's why Big Bang and black holes are so popular, is because that's where a lot of money flows into. But anyways, the nebula hypothesis, here's a daily and monthly chart. Daily on top, monthly on bottom. And you see those spikes? Those spikes are the end of the spring semester where astronomers all get together and they hold big conferences and they try to figure out where they went wrong. And they try to figure out where they're going to go next. They got to talk to one another, be like, where are we gonna find our next bunch of gold? How are we gonna get our next paychecks? Or is it wise to continue with this theory, or is it unwise because it's not gonna bring in money? So that's basically what they're doing. And with the history of solar system formation and evolution hypothesis, you can see here's a daily, and here's the monthly chart, and you see how it goes up tremendously. At the end of every spring semester, it spikes like that. And what this tells me is that they go to the history of solar system and solar system formation and evolution hypothesis because they're trying to look to see where they messed up. They're trying to figure out where they went wrong. And they're trying to look for an idea that they can push upon the people with textbook information, and that they can continue on getting paid and doing what they're doing. And so far, they don't have any way forward. So either they find a way forward, how do I put this? Either they find a way forward that gets them money, or if they don't do that, then what's going to happen is they're going to be looking at ideas that they don't know is going to make money or not. And that's where stellar metamorphosis comes in. Because they'll be able to branch out and go out on a limb with ideas that they know isn't going to make any, or they don't know if it's going to make any money or not, versus continuing pushing a theory that's going defunct. And the reason why I know this is going defunct is because the nebula hypothesis, this is linked to the bottom, of course, you guys can see this too. The nebula hypothesis is the blue line, and the green is the history. So look at it as the history is them trying to figure out where they went wrong, and the blue is them hunky-dory, everything's okay. We don't have to actually make sense because the Nebular hypothesis in the textbooks brings us money and it establishes careers and stuff. But as you'll see, here's 2016. When you get to 2017, it flip-flops. You see, the history goes higher than the Nebular hypothesis. And then it becomes more pronounced in 2018. And then 2019, they're starting to jump ship, okay? Look how much higher that is. That signals to me that they're realizing, with all the exoplanet stuff out there, which are evolving stars in this theory, that they're severely, let's put it like this: they're stuck between a rock and a hard place, because they can't keep on going pushing wrong theory even though it makes money, when that theory is completely false and doesn't match any of the observations. So it's kind of weird. It's like it's in one of those spots of history, if you will, where no matter how much money you pour into something, you can't make it correct with social status. You can't make it correct with politics. You can't vote it to be correct. You can't push it in propaganda because people will always constantly call you out on its problems. And all the billionaires and all the governments in the world can't put the Nebular hypothesis back together again. It's like the Humpty Dumpty story. Humpty Dumpty sat on the wall. Humpty Dumpty had a great fall. And all the king's horses and all the king's men tried to put Humpty Dumpty back together again. Yet they couldn't. So what's happening is a Nebular hypothesis is having its Humpty Dumpty moment. Where in 2017, it flip-flopped, because you can tell, because the astronomers are going back to the history saying, where did we go wrong? Why would they be doing that if the Nebular hypothesis was the way forward? They wouldn't be going back to history articles to look back to see where the problems occurred. They would be just fine. There wouldn't be any big spike in the history article. They wouldn't even look at that at all. They would know what they're talking about. They would know what they're doing. The fact that they're looking at the history article is telling. And that being said, I also have another paper here, Origin of Species by Charles Darwin versus Stellar Metamorphosis, Absence or Rarity of Transitional Varieties. I'll read some of this out to you guys. The abstract is: a short parallel is drawn up between Darwin's Origin of Species and Stellar Metamorphosis in relation to the absence of rarity of transitional varieties. It is made clear in this paper that both are quite similar in their trouble, but both can be explained in light of their own progresses. To Darwin, Earth was a large museum, or is a large museum. Literally the best museum ever, because we found freaking things that are hundreds of millions of years old in fossil form. We dug them up, and then we put them into our museum. But anyways, Earth is the ultimate museum. So if you find an organism that is fossilized, and you find another organism that's fossilized, and you have a theory of evolution, you have two different organisms. They look different in their fossilized form. So to a bystander, they think, oh, well, they're different organisms, clearly. But what Darwin is saying is they're related somehow, even though they're found in different spots, they look different, and they're different ages, and all this other stuff. So evolution, the theory of or the origin of species, is they all had a common ancestor, so they're related to somehow, which means the transitional varieties should be dotting between the center of those two organisms. There should be organisms that connect it to, fossils that look a little bit like this one and a little bit like this one down here. But that was the big problem, because back then they were like, there are no transitional varieties of humans. Humans formed as is. We were, created by God and all this other stuff. And there was a big rift back then between them, saying, "Oh, we didn't come from monkeys." But that wasn't the argument. The argument was we have common ancestors. So the family tree branches out, and the further you go back, you have ancestors that have similarities, but it isn't we came from them, is that we evolved from a common ancestor. So both of those organisms have to move up the tree at the same time to find a common ancestor. It isn't we moved horizontally from chimps. It doesn't like that. And those transitional varieties were dug up in the future, and we found more organisms that connect the dots, so to speak. And the same thing is with stars and planets. Back in the 1800s, early 1900s, astronomers were looking up at the stars and thinking, well, those are the stars. And then they looked at the solar system and say, these are the planets. And then they separated them in their minds. There was no concept of transitional variety for these objects. They formed as is, just like humans did with the creationists. Humans formed as is, and then they remain like that forever. But now that we're finding objects in the galaxy that are different sizes, different masses, different orbital parameters, different everything, it's becoming clear that they're transitional varieties. It's becoming clear that planets evolved and are evolutionary structures. They're not structures that formed as is per the Nebular hypothesis. The Nebular hypothesis says they all formed around the sun as is with the same chemical composition, same mass, same everything, and they're going to remain like that forever. That's wrong. They're transitional varieties of a vast evolutionary scale. And I'll go ahead and link this paper to that. And that's going to be the big riff. Nebular hypothesis is more or less a creationist type idea, and stellar metamorphosis is an evolutionary idea. That's the big riff we're going to experience over the next couple of years. All right, guys, take it easy.